Hello, my dear students. Welcome back to the lecture. So, here we'll try to see how any building has to be planned. So far we understood the architectural plan and all. But have you ever thought like why the kitchen is kept here? Why the bedroom has been kept here? Why the master bedroom here is here? Why not the master bedroom has come here? Why not this particular kitchen has come in the center and has bathroom has gone in this portion? So, there's something called as Vastu. Okay, this is specially applicable all over the world. Especially in India, we apply that. But if you are from other country other than Indian countries, even everywhere we apply this concept of Vastu. But it all depends whether you really believe in that or not. Okay, so that is a basic principle behind the Vastu. So to put it in a better way, what exactly is Vastu? For example, it's yeah. So Vastu is nothing but it's about balancing about the positive and the negative energy in your location. For example, this is my home, right? So this is a building for me. Okay, so in this building, I'll try to balance positive energies and the negative energies so that the person who is staying in the home, that doesn't have any effect on him, right? See, whenever we construct any home, our main intention is what? To stay in the house happily, right? So that is the main intention. If that happiness itself is not there, what's the point in constructing a house, or what is the point in having a family and all? So that is the main idea behind the Vastu. Okay, so what we basically do, I'll start with this now concept. Okay. First, I'll give you a small introduction about what are the different directions we have, and we'll try to see the history about the Vastu, and then we'll see where the kitchen has to come, where the bedroom has to come. Okay. So give me a minute. Yeah, so we'll start with this. Okay. According to the Vastu Shastra, the entire universe exists in endless space and has no direction whatsoever. However, on Earth, our directions are defined with respect to the sun, and there are 8 cardinal directions. Now, there are altogether 8 directions. In that, one is each direction, which is called as Purva according to the Vastu. Okay, I mean Purva according to, in Hindi we call this as Purva. Then we have West, which we call it as a Paschima direction. Then we have a North direction, and then we have a South direction. Even if you see our globe, the entire universe, we have North Pole, we have South Pole. Okay, in the same way, we have North, we have South, we have West, we have East. Right? Very simple. Same thing is here: East, West, North, and South. Okay, and along with that, we have another 4 directions, which are called a sub-cardinal direction, like northeast. Northeast in the sense it is where the north and east meet. Like if this is my north, this is, I'll say this is my north, south, west, and east. So north and east, in between this there's one more direction which is called as northeast. Northwest in the sense west and north and west, in between that we have one more direction which is northwest. And then we have southwest, south, and west. In between that we have one more direction which is southwest, and then the southeast, south and east. In between that we have another direction. Altogether, we have 8 directions. Very simple. Yeah. Now, we'll see the m- main idea behind that. Quickly, I'll try to read it. The sun sustains life and is very important to living things. Since the directions are defined with respect to the sun, the cardinal directions are also an important Vastu factor. In Vastu Shastra, it is believed that the right disposition of the rooms of the house with respect to the 8 cardinal directions has a direct positive influence on the residents, like I mentioned about the positive and the negative energy. Since the Vastu Pandits knew of the importance of sunlight to the humans, along with the sun, the 8 cardinal directions were taken into account in the design of a building. The main aim of Vastu Shastra is to ensure that the inmates of a house are inadvertently exposed to the useful rays of the sunlight, even if they are inside the house the whole day. But during a day, the people perform different activities in different rooms at different times, and the sun's position keeps changing with respect to the cardinal direction. Very simple. So early morning, your sun starts from the east and it goes all the way to the west. So every now and then your sun keeps on, what will happen every now and then, the sun direction keeps on moving, right? And you'll be perform different activities. Like for example, early morning you wake up, the first activity what you do is you go to take bath, then you come, you have your breakfast, then you leave home. Afternoon you come back, you have your lunch, then you take a small nap, you have a different room to that. Evening you perform some rituals at home, let us say you do puja and all. Then night you have a dinner. So all these rooms have, I mean, for whatever activities you are doing, you have different room to that. And when you're doing a different activities, the sun keeps on rotating, isn't it? So that is the main idea behind that. So to ensure that the inmates get exposed to the sunlight constantly, each room should be positioned in a specific cardinal direction so that it faces the sun at a time of a day when it is almost likely to be used by them. Now we'll come to the main interesting part. See here. Okay, now it will start at 3 a.m. in the morning. So morning 3 a.m. to 6 a.m. early in the morning, just before the sunrise, is called as Brahma Muhurtam, and the sun is in the northeast. Hence, this is the right location for the meditation or the puja room. Now you understood. Now I'll show you all these things through a plan only. So 3 a.m. to 6 a.m. is a time which is called as Brahma Muhurtam, and at this particular place, at this particular time, the sun will rise in the northeast. And so this is a good place, or this is a good direction to have your puja room. So that is why whenever we construct a home, we say that northeast is a place where the puja room should be there. So that is why, because from 3 a.m. to 6 a.m. the sun will be there. 6 a.m. to 9 a.m. the sun is in the east direction, because from the northeast it will come to the east direction, is in the east. This is the right time for bathing, and so the east is logically the best position for the bathroom. So that is why whenever we keep the bathroom and all, we try to keep the bathroom in the east direction. Okay. Next, 9 a.m. to 12 noon, the sun is in the southeast direction. That means south and east. In between this, we have sun from 9 a.m. to 12 a.m. And this is a good time to prepare and eat food. Hence, a kitchen is the best located in southeast. That is why we always keep our kitchen in the southeast direction. And if I show you, of course, I'll show it later through a plan. For the same plan which I explained, that put the kitchen in the southeast direction. Now, noon, that is from 12 to 3 p.m. The sun is in the south, and since this is the right time for resting, it makes sense to have a bedroom in the south direction. So you can have your bedroom in the south direction. 3 p.m. to 6 p.m. The sun is in the southwest, and this is the right time for studying. And so the southwest is a good position for studying. And even in the southwest, you can have your master bedroom, not an issue. From 6 p.m. to 9 p.m., what will happen is the right time for having a dinner. That is the usual time what we have. 9, some people will have 8, 8:30, or 9 is a good time to have. We don't have at 6 unless you are on a strict diet. Okay. The sun is in the west at this time, though it may not be visible. Hence, the west is a good time, or is a good time and a good place for dining room. Okay. So that is why whenever we plan the dining room, no, we try to keep it in the west direction. Now you may ask, the morning, afternoon also will have a food in the afternoon also will have a food. That time sun will be in the southeast. No, see, this is the main idea behind that. Again, will if you try, when you try to dig in more, you get more other opportunities. I mean, you get more other things, and based on that, we are going to plan. Okay. 9 p.m. till morning 3 a.m. in the morning, the sun is in the north, and it is the right time for rest and a sleep. Okay. So you can have your bedroom even in the north direction. You got my point? So this was the whole idea behind the Vastu. So I hope with this, you have at least got a concept why actually Vastu is important, based on what factors we are going to do. Now you may ask me one question. So why is that this Vastu is being, more pushed nowadays, whether the Vastu was not there in the earlier times? Of course, in the earlier times, okay, maybe in the 15th century, 16th century and all, there was Vastu. Back those days, what used to happen, let me explain here. Back those days, even that time also Vastu was there, and people were knowing all these things. But what was happening those days? Yeah. Okay. So those days, what used to happen? People had enough space, right? So if you remember your ancestors and all, they had a good land, isn't it? They had ample space. I mean, they had ample land with them. So there was no problem. Like if this was my entire land, whatever I could have constructed my house the way I wanted, right? But with industrialization and with people moving to bigger cities and all, what used to happen? The places got jam packed. That means whatever. See, for example, when you go to a bigger cities and all, you don't find such a big plot. What used to, due to industrialization and all, what used to happen? I mean, due to urbanization and all, what used to happen? The space whatever you had, no, it all got compacted. So earlier this was a space one person was having. So when, due to more population, due to urbanization and all, what happened? People were having only this much space. Now instead of this space, they were only having this much space. Now compared to this particular space, this particular space is very compact. Now you want to construct the same house, even though you had a big plot. Your aim was to construct a 3 bhk or a 4 bhk house. Now in spite of having such a small area also, you want to construct a 3 bhk house. In that case, you cannot expand that. You can go at the higher level, like 1 floor, 2 floor. You cannot expand. Since your land got compacted, we try to adjust instead of, for example, instead of keeping a bathroom here, since we didn't have space, we kept our bathroom in some other direction. Instead of keeping your bedroom in the southwest direction, since I didn't have a space here, I tried to shift. Because of that, what happened, the whatever earlier people used to do, our ancestors used to properly plan, and then they used to construct. They had a knowledge of Vastu, but due to this space compaction, I mean due to this problem with urbanization, and people had very less land, what happened, they started to construct the house on their own without keeping this, or without violating the Vastu. So that is why this Vastu is booming nowadays, because people, lot of people are facing the problem. Why they are facing the problem? The reason is that they are not properly planning it. Wherever the kitchen should come, that is in southeast direction, the kitchen is not coming. Your bedroom should come in the southwest direction. Since you don't have a space, you put your master bedroom in the northeast direction, which is not meant for bedroom. So this, because of this reason, what has happened, a lot of problems are occurring. So that is why Vastu plays a very crucial role, at least in Indian condition. Even in other condition, like if you go to foreign countries, even there also Vastu plays an important role. But there it depends, because we have something called as northern hemisphere, and we have something called as southern hemisphere, right? So it depends. Based on that condition, we have to plan it. But Vastu is a scientific science, and it applies to everything, because we don't have a control. It is completely controlled through the sun and other planets and all. Okay. So here quickly we'll try to see the different directions, and we'll try to understand the concept behind that. Okay. So it all started, like, see, if you remember, whenever we start with the construction of any building, we do a puja, right? We perform a ritual which is called as Bhumi Puja. Okay. And whenever we start any big project, the first thing whatever we write in the project planning is that we write that today we are going to do a Bhumi Puja, and then your execution, the mobilization, all those things starts. Good, very simple. Now, the reason behind doing a Bhumi Puja is because of this person. This person, you can see this person. So this person is called as Vastu Purush. Okay. So this is the entire home layout. Now you may get certain idea what I'm trying to tell. This entire guy, this entire is a home layout. Okay. This is where you're constructed. Put it in a different color. This is your home. Okay. This is where you're constructing your home. And your Vastu Purush is something, your Vastu Purush is sitting something like this. So this guy is your Vastu Purush. This is the head of that Vastu. Purush is a man. Okay. So Vastu is sitting something like his limbs are here. Okay. His both the feet are here. And then he's sitting in this way. You got an idea, no? See, you can see he's sitting something like this. Okay. Got it? Yeah. So based on that only we are going to plan. How we are going to plan? It's very simple. This entire plot we are going to divide it in 9 parts. That means each direction we are going to put it in 9 parts. For example, I'll quickly put this in 9 parts. Okay. So if this is my entire length, if this is the length of my, I'll put it in a different color. See, initially you may find it a bit difficult, but this is how you're supposed to do. Okay. Yeah. So this is my length. Let us consider this length is something 9 meter. Okay, this length I'm considering it as 9 meter. Now what you're supposed to do, you have to divide it by 9 parts. Whatever may be the length of your plot, you have to divide it by 9. So 9 divided by 9 comes out to be 1 meter. So for every 1 meter, I'm supposed to draw the line. Okay, so that is what I'm basically trying to do. I'm basically trying to put the grid lines. Okay, we'll start with this. So one grid line. This is my second. So you can see the same thing which has been done there. So 3. Now, why it is 9? So that is how the Vastu, this thing has been come up. Okay, even I don't know the real reason why it has to be 9, why not 10. But there is something called as 8 also. When you're constructing the temple and all, I heard it is for 8. So I don't have much idea on the temple construction, but in the temple and all, we go with the 8 by 8 grid and not 9 by 9 grid. Okay, so this is done. In the same way, I'm supposed to do in this direction also. Now let us say if this is my direction again, in this direction, again, I'll do the same thing. I'll go with a different color, or let me go with the same color. Yeah. Here also I'll divide it by 9 parts. So in this way, we are going to construct all these grids. Okay. These are the grids what we have constructed. And now in each grid, we have 3 parts. So this is my 3 part. I'll do it in 3 parts now so that you get an idea. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So these 3 are one grid. Okay. Then I'll go with a different color now. These 3 are another grid for me. Then these 3 are another grid for me. Okay, got it? Then I'll go with a different color again here. These 3 are another grid. These 3 are another grid for me. Then I'll go with another color. Yeah. So these 3 are another grid. You can see 3 by 3 grid. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is also 3 by 3 grid. This is also 3 by 3 grid. Okay. Now this is how our entire layout is. And now this is we are going to write. And now we are going to write all these things. Like I'll write this is my north. Okay. This portion will be my north. Okay. I'll write it here. This entire portion is my north. Think it's not visible. I'll do one thing. Yeah. Yeah. This is my north. I'll go with a different color. This is my north direction. This entire thing is my south direction. This entire direction is my west direction. This entire direction is my east direction. North, south, west, east. This becomes my exactly northeast. This becomes my southeast. This becomes my southwest. This becomes my northwest. You got an idea now? So this is how the entire building will be planned. And now based on that, we try to keep in this portion only my northeast, what will come? Puja room will come. In each direction, you can keep the entrance of your home. You can keep your bathroom also. Southeast is always meant for the kitchen. So in this entire portion, you can plan your kitchen anywhere. South, you can try to have a bedroom, not an issue. Southwest, you can have your master bedroom. I mean, you know, you can, it's not you can, you have to keep your bedroom, master bedroom in the southwest direction. West, you can keep the toilet. East also you can keep. And west is also a good place to keep toilets. And northwest, you can keep your kids' bedroom, or even you can make bathroom and all in this portion. This is Brahma. Brahma is the center portion. And as far as possible, the Brahmastan, this particular should be kept open. You should not do any construction in that place. Why is that so? Because this is the center of a Vastu Purush. So where is the center? So this entire portion, if you look into the Vastu Purush, his stomach is in this portion. You cannot put a weight on someone's stomach, right? So this Vastu Purush, you're not going to do anything here. Okay. And this is your northeast direction. Along with that, this is not the only concept. Along with that, each direction has its own importance. Like for example, now it becomes a bit complicated. One thing is about the Vastu Purush. This is what we are supposed to keep in mind. The second is about the directions. So we'll see what are the directions, and see we have 5 major elements, right? If you remember, we have something called as water. What are the elements we have? One is water, then we have air, then we have fire, then we have space, and we have I think I left one more thing. Which is that one more? Let me write it here. Yeah. Yeah. Water, air, fire, space, and this water, then fire. Yeah, earth is a one more element. Yeah. Another element is earth. Okay. So these are the 5 elements. This is called as earth. And this 5 elements, we have their own place. Like this element, this particular area is meant for water. Okay. This is meant for water element. This also you have to remember. Wait. Water element. This particular, that is southeast, this is meant for fire element. So that is why we keep our kitchen in this direction, because we have fire element here. Okay. Southwest. Yeah, fire. Okay. Then my southwest, this is for earth element. Yeah, this is for the earth element. And northwest, this is for air element. Okay. This is my air element. And the middle space what I have, this is my space. Okay. So that is why it has to be open. You're getting my point? So this is how the another planning will be done. This is based on the different this thing 5 elements, what we call water, fire, air, earth, and space. Got it? So I hope your concepts are clear up to here. And now we'll try to get into the other concept, that is where we are supposed to keep water elements. So first I'll start with the north. First we'll start with the northeast. So northeast portion, what all things you can keep? You can always keep in the northeast your puja room. You can have your living or a formal room. You just have to note down these things. If you don't note down anything, I don't have issue here. But try to note down whatever things I've written it here. And the same we'll take up 1 or 2 plan, and we'll try to implement this. Okay, northeast is also called as Ishanya, and here we have water element. And the planet, whatever we have a Jupiter planet here. So you can have your puja room here. You can have your living or formal room here. You can have your bedroom, that is kids or guest grandparents bedroom only you should have. Well or underground tank can be kept in northeast direction. And one thing you remember, you should not create any bathroom in the northeast direction. Why? Because northeast is a place where Jupiter, and Jupiter is a god for us. Okay, so that is why we are not going to construct any bathroom here. Another reason is that, where is this Vastu Purush head? The Vastu Purush head is in this direction, and this is my northeast. So in someone's face, you have made a toilet, which means you have made his face dirty. When you are giving problem to the Vastu Purush, in turn he will give problem to you. So that is why we don't keep this thing, bathroom, in the northeast direction. That is the main reason behind that. Now come to the southeast portion. Southeast is called as, which element we have in southeast? It is written here. Okay, we have fire element, and the god which is this Agni Dev. So since it's a fire element, we try to keep something which is related to fire. So in the kitchen we do fire. I mean, in the kitchen we do cooking, which is connected to the fire. So that is why kitchen will try to keep in southeast direction. And also the electrical equipment. See, this Vastu is not only applicable to the building. Okay, I mean, not only to a residential building, it can be for commercial and all. In commercial, you don't have kitchen and all, right? So maybe you're putting up a factory, maybe you're putting up a big commercial building like a mall and all. So in that case, you'll be having a lot of electrical equipments and all. So those things you can keep it in the southeast direction. Now come to the southwest part. So in the southwest, this particular place is called as Nairutya, and the planet what we have is a Earth planet. Okay, so always we need to keep our master bedroom there. So what is master bedroom? If you have a home, if your dad is the head of that family, or someone who is the head of the family has to sleep in that room, so that is a southwest direction. In this room he has to sleep. Why? Because Earth is the element. So Earth element we need to keep stable. Earth cannot become unstable, right? Earth has to be stable. Only then we people are stable. We are staying on the Earth. So the head of the family should be stable. Only then the entire house can be stable, and you can have a good atmosphere there. So keeping that in mind, what we do in the southwest, we try to keep the master bedroom. Not only this, there's one more reason to that. So in the northeast direction, we have Jupiter god, isn't it? If you see, this is water element. We have Jupiter. Jupiter is a god. So God is directly seeing from here. What is the directly direction? He's seeing here. So that means God is always giving a blessings to everyone, right? So when you have a master bedroom here, so main head of the family is sitting here, he's sleeping here, or he's sitting in that room. So the God is always blessing him. So that is another reason why you are supposed to have a master bedroom in the southwest direction. Now come to the next part. The next part is a northwest part. So northwest we have, it is called as air element. There is an air element, and it is called as Vayuvya. So since it's an air element, whichever element which is which is in a movement, we are supposed to keep it there. For example, we try to keep kids bedroom or guest bedroom in the northwest direction, because the kids, we don't want them to stay in the home for a long period of time. I mean, if they want to go for higher studies and all, we usually make them sleep in the northwest direction, because that northwest will not allow them to settle there. They'll try to push it, since there's an air element here. So that is going to have the effect on those people people sleeping in the northwest room. In the same way, we want a guest bedroom in the northwest direction. Again, whenever the guests come to our home, we don't want them to stay for a very long period of time. Hence, they are called as guests. Someone who comes for 2 to 3 days, they are called as guests. So if they stay in a home for a very long period of time, it's difficult for us to cope up with them. So what we do, usually we plan our guest bedroom in the northwest direction, so that air element is there, it will push them out. So they don't stay for a long period of time. They run out from, I mean, they go quickly, right? That's the first option. If you cannot keep a northwest, if you cannot keep kids bedroom or guest, see, whatever I'm telling, it is according to Vastu. Now it's not that in all the plan you can apply all these things. It's not possible. Some plan may be like, for example, you don't get a plan something like this, right? All your home plan won't be like this. Some home plan may be something like this. Okay, in that case, what you're supposed to do, you may get a house plot something like this, which is something like this. Okay, something cut like this. Okay, in that case, what you do? You have to construct home. You cannot say that, no, I'll be having only a rectangular plot. I'll be having only a square plot. You may get a plot something like this. Like, for example, yeah, I have this portion, and I have this portion. I have this portion, and this northwest portion is cut, and this is a plot what I have. In that case, you don't have northwest in your part. In that case, you have to plan accordingly. No, that is why sometimes if you cannot keep your this thing, kids bedroom and guest bedroom here, you can have your kitchen. Of course, first option is southeast. If you cannot keep your kitchen in the southeast, you can have your kitchen in the south northwest. Again, what is the reason? Because northwest is what element? Air element. Air and fire can be together, right? Air and fire, because for a fire to catch, you need a air, that is oxygen is required. Air is oxygen. So in the northwest, you can have a kitchen, but you cannot have a kitchen in the northeast direction. Why? Northeast is a water element. So you cannot have a fire and water together, because they're two different things. For a fire to be for a fire to dose, you want water, right? Very simple. If you want to dose the fire, you want water. That means fire and water are not good friends, whereas air and fire are a good friends. So that is why northwest is a good place where you can have your kitchen. It's the second option. Just in case in the southeast you cannot have your kitchen, you can have your kitchen in the northwest. Toilets are the good place to have in the northwest direction. Staircase is also a good place to have in the northwest. And finished goods, so this is applicable in the commercial buildings and all. Or maybe if you're putting up a big showroom, or if you're having a jewelry shop, or let's say if you are into the this thing, what is that, uh, clothing business, where you have a uh, let us say you are into a automobile industry, where you have finished goods like car. Okay, now car is a finished product, you want that to come in the market. So where do we store that? We store it in the northwest direction. Since northwest is a air element, the moment you store the car in the northwest direction, due to the air element, it will push. That means more customers will come, it will take your car. I mean, the good sales will happen. That's the logic behind that. Not only for the car, whatever are your finished products, like if you're into a jewelry shop, you keep all your jewelry in the northwest direction. We plan in that way. In the same way, what is that, if you're into the clothing business and all, okay, then try to keep your showroom or the display unit in the northwest direction, so that what will happen? Yes, the sales will happen quickly. Very simple. So I wanted you to understand all these things. So for the same plan, we'll see how the Vastu concept has been applied. Okay. So first try to understand. See, they have given the direction that this is north, south, east, and west. So I'll plot the same thing here for our understanding. So I'll write here, this is my north. Okay. Then, okay. This is my north direction. Uh, then this is my south direction, north, south. Then this is my east direction. Okay. And this is my west direction. Okay. Great. Other than that, if this is my direction, it comes out to be southwest. This will become my exactly northwest. This becomes my exactly northeast. Okay. And this becomes my southeast. Okay. This much is understood. Now, first we'll start from which I'll ask you one room. You just answer me. I see, will not apply everything. Let me make it very simple. We'll see, main is our master bedroom. I want master bedroom. Then I want my kitchen. I want kitchen. And then I want bathrooms. Uh, then I want puja room. Okay. And then I want entrance. We'll concentrate only on these things. We'll see. There might be some spelling mistake. Okay, wait. Entrance, puja, bathroom, kitchen. Great. So these are the things what I'm looking for. First, let me start with master bedroom. So what is the best location to have a master bedroom? I told you to write it. Just see your book, what you have written. Southwest is the best part. Now, can you see these people have put a master bedroom here? So this is my southwest. Okay, this is my southwest portion. Again, how is this my southwest portion? You know that now. You have to entirely see. This is the entire building what I've done. Okay, my building is up to here. This is my building. Okay, staircase will take it later. This is my entire building. I have to divide it into 9 parts. I'll quickly do it for you so that you get an idea. Okay, so this is part 1. Okay, I'll do one thing. Instead of this part, no, I'll make that 9 square so that it is easy for us to understand. So this is my 1 square. This is my square 1. Okay, this is my which direction? Southeast. This much is my south direction. This much is my southwest direction. Okay, then this much is my east direction. Then this is Brahmasthana. This is my west direction. This is my northwest direction. This is my northeast direction. And this middle portion we have this as north direction. Now you are okay with this. Now we'll try to understand. Okay, Where is my master bedroom? It should be in north southwest, right? So you can see this is my southwest. Agree? So I have a master bedroom planned here. Good. Coming to the kitchen. What is a good place to have a kitchen? Of course, southeast is a good place. So can you see this is my southeast? This portion is southeast. I kept my kitchen it here. Now come to the bathroom. Bathroom, I told you can have it in the east or you can have it in the west. West is always good. So you can see there is one bathroom here, bathroom here. Which portion is that? It has been kept in the west direction. Now come to the puja. Puja, actually puja room northeast is good. That is, this particular portion is good for puja bedroom. I mean, sorry, puja. If you cannot keep it here, even east is also a good place. So you can see this puja. They have kept it here, and it is in the east place, almost in the east. I mean, close to the southeast. It is in east portion. This is also okay, not an issue. Okay, yeah, great. And now coming to the other part. Other part, you see here. This is one more bedroom. What they have done. Maybe this bedroom they are going to use it for the guest because this is master bedroom. This is one more bedroom. Even in the south also you can have a bedroom. This particular bedroom they may use it for the kids or they may use it for the guest. Again, where is this particular bedroom? Again, it is in the northwest direction. That is why we keep it in the northwest. And I told you staircase can be kept in the northwest. So you can see this is northwest, staircase is here. You can keep your staircase in the northwest direction. Got it? Yeah. So whatever I had explained you, everything you can see it here practically. Okay. Now coming to the entrance part, I'll take out everything now. This is no more required for us. I'll take out all these things. Okay. Come to the entrance. So where is the entrance? You're making an entrance from here. So always a northeast entry is always a good. Like this is north. This particular is northeast. Like this particular region. This is my northeast. Okay. So northeast entry home are always good. So you can see you're making an entry from the northeast. Okay. So why is that so? Because north you have your Jupiter god, I mean Kubera, and east you have sun god. Okay, so because of that, what we try to do, try to keep it in the northeast direction. So and there also you have this Jupiter god, and because of that reason, we try to keep the entrance of a home in the northeast direction. East is also a good place. You can instead of northeast. I mean, if you don't have a space in the northeast, you can even give an entrance of your house from the east direction. East is also good because east we have sun planet, and sun since we have sun planet, we can have our entrance in the east direction because the moment you open your main door, the sun rays are going to enter in your home. Through that, what will happen? You will have a positive energy. So that is why always we say east and northeast are the good place to have your entrance of the home. So you can see we have kept our entrance in the northeast direction. Very simple. Okay, never try to keep the entrance of your house in the southwest direction, because southwest direction we don't allow this thing, that is the door, I mean main entrance, to be in this direction. South facing houses are also not good unless you plan it properly. So never have a main door from the south direction. North is good, you can have a door in the north. Northeast is always good. East is good, then you can come for the north. Okay, so this is how it is. Other than that, most of the things whatever we learned, we have practically applied it here. Okay, and this was my ground floor plan. In this way we have planned it. And see, you can have your this thing, living room and all, in the north portion. This is almost in the north portion and northeast portion. It's a good place to have your living room, veranda and all. Okay, and then your this thing, what is that, dining, you have kept it here, and it is somewhere in the middle of the home, and it is okay. Okay, not an issue. You can keep it, you can keep your bed, this thing, dining table here, not an issue, right? Main is safe. The main, always remember, you just have to concentrate on four part. That is, kitchen should be always in the southeast. Your master bedroom should come in the southwest. Your kids bedroom can come in the northwest, and entrance try to keep it in northeast or east. If you balance this four, no, automatically everything, the other things will get set. And as far as possible, try to keep your bathroom in the west direction. Got it? Great. What are the minimum sizes of the rooms that we are supposed to keep? And also it will be a kind of assignment for you. So quickly try to note down the things what I'm trying to tell, so that whenever you try to do a planning of any house or any of the building, you will have a rough idea, so that what should be the minimum sizes you're supposed to keep. Okay, so we'll start with this. So yeah, yeah. So first, these are the standard room sizes what I have. Okay, so the foyer, then we have the powder room, then we have living room, dining room. Yeah. So the dining room, the family room, recreation room, media room, kitchen, eating, pantry. You can see if you're putting a small, then you can take this as a rough sizes. If it is a medium, you can try to keep these sizes. And if it is for the large, you can try to keep these sizes. Okay. So just have a note down of this. so that you can use it as a rough dimensions, and you can do a planning accordingly. So along with that, this is one more thing here. What is written? Yeah. Again, for the living room, dining, kitchen, utility room, bedroom, master bedroom, bathroom, servant quarter. If it is a small, you can use this size. If it is a medium, you can use this size. And if it is a large, you can use this size. So with this, what we can do is we can have a planning. Whenever we try to do a planning, we can try to make use of these dimensions, and we can try to do that. Very simple. And keep Vastu in mind, like which room and which area, what room should come. Now, what we can do is I'll be taking you to few of the drawings. Okay, and just see the dimensions what they are given. You can even note down this so that you can make use of this. Okay, this is one of a house plan again. So quickly try to understand. You see, if someone wants a puja room, a 4 feet by 6 feet 6 inches is a good puja room what you can keep. Okay, then, because why I'm showing you all these things, these are the houses which are already built. So that means the client is okay with these sizes, and you can use these sizes. If you want to put up a kitchen, take 9 feet into 9 feet 6 inches is a good size to have a kitchen. Now, based on your client requirement, you can make this as 9 feet by 9 feet, or you can make this as 10 feet by 10 feet. Depends on the requirement, depend on the length what you have. But at least to get a basic idea, you can start with this. You can take a common toilet which is of 6 feet by 5 feet. Your bedroom can be of 9 feet by 12 feet. 9 feet by 12 feet is a good dimension to have for the bedroom. It's a bit spacious, and it's a very good size what we can have. And then attached toilet can be of a 9 feet by 4 feet. Master bedroom can be of a 12 feet 6 inch by 12 feet 6 inch. Always master bedroom we try to keep a bit what do you call, the size is more, dimension is more compared to all other bedroom. Okay, and then for the living you can go with a 10 feet by 17 feet 6 inch. Again, it depends, there is no constant to that, because it depends what are the surrounding areas, and whatever is left out, that will be taken as a living room. Very simple. And the staircase, you can take the width of the staircase, I mean the width can be taken as 5 feet 9 inch. Got it? So this is what you're supposed to understand. I'll take few more plans so that you get an idea. You can see this particular area. We'll start with this. So they have taken a bedroom of 11 feet 7 inch by 12 feet, like I mentioned. So what is the difference between this? 9 feet by 12 feet, whereas here it is 11 feet by 12 feet. Okay, you can take a toilet of 7 feet 3 inch by 4 feet 6 inch. Store can be of 7 feet by 3 feet. And this is a kitchen, a L-shaped kitchen what they have given. Okay, and then yeah, that's it. So other than that, it's a very small plan, because they have I mean, the space restriction is there. They don't have a rectangular plot, and if you see it here, see the space, they have only this much space here. So that is why they have planned it something like this. Not an issue. We'll take one more. This is one of a commercial building where they are planning to put a shop here. They have a shop here. So just have an idea regarding what is the dimension of a shop they have kept. So they have kept this as 14 feet 6 inch by 29 feet 6 inch. You can even break down into two parts. If you want to make this as a two shops, you can put one more wall here, and you can convert this into two shops. These people wanted a bigger area, so they have made this as one single shop. This is one more shop. This is another shop. Again, this can be converted in this way. We can put a wall here. So this will be another shop, and a big shop here. And the staircase, you can see the width of the staircase, they kept it as 10 feet here. And this is 5 feet, 8 inches. And overall the length is 21 feet. Good. We'll go with one more now. Yeah. So this is one more 5 BHK plan what I have. So these are the standard dimensions, and this is very spacious house. Okay, it's a 5 BHK what we have, 3 in the ground, and sorry, 2 in the ground and 3 in the first floor. So this is a sit out area. You can have a sit out of 6 feet 1 inch by 10 feet. Okay, 6 feet 1 inch by 10 feet. A small foyer has been made here, which is 10 feet by 10 feet, or 10 feet 9.5 inch by 10 feet. Then again, this is a formal or a living hall, which is again 17 feet by 20 feet 6 inch. Okay. Now you see the kitchen. Kitchen, it is bit spacious, which is again 13 feet by 17 feet 6 inches. Then we have a storeroom here, a utility room here, and then I'll enter into the master bedroom. Again, you see the dimension of a master bedroom, which is almost 13 feet by 17 feet 6 inch. It's more spacious. Okay, and then you can have a puja room of 9 feet by 9 feet. Then another bedroom which is 13 feet by 17 feet 6 inch. And yeah, the toilet which is almost 9 feet by 7 feet 3 inches. Got it? So in this way you can plan, and this is a huge, I mean a big dining hall what we have, which is almost 18 feet by 18 feet. Okay, got it? So you try to note down these dimensions so that you get an idea. Other than that, yeah, I think these were the things what I wanted to inform, what I wanted to talk about. And then let me take one more plan so that we get some more idea. So again, this is one more drawing what I have. Okay. So what they have is they have one bedroom here, and I think yeah, there's only one bedroom in the house. There's only one bedroom here, and other than that they don't have much thing. Okay, so what they have done, we'll look into the bedroom size. Again, it's a 10 feet by 14 feet. See, 10 feet by 14 feet or 12 feet by 12 feet is a good size to have a bedroom. Okay, and then they have made an attached bathroom here, which is almost 10 feet by 5 feet 4 inch. And then they have a utility area which is almost 6 feet 4 inch by 9 feet 8 inch. You can have a bath of 5 feet by 6 inch, a water closet of 4 feet by 3 feet 6 inch, and then a parking area has been made. Parking area and all, there is no standard dimensions. It depends on your plot area, but whereas your this thing, master bedroom, utility, all this other have a standard dimensions which we can make use of. Yeah, look at the puja room, which is 5 feet by 5 feet. They could have made this as 6 feet by 6 feet also, but they have made it as 5 feet by 5 feet. Pretty simple. Great. So I hope by this time you got an idea regarding the dimensions and all. Try to note it down, like I mentioned, and you can have a fair idea whenever you are supposed to do a planning. You can try to play with these dimensions and give a proper plan. Great. So what assignment you're supposed to do is, already initially I had taken 3-4 plans in the initial lectures. Try to note down for that also, so that you can have a good understanding of the dimensions. Great. So far we understood about the architectural plan and all those things. But have you ever thought like how the beam sizes are decided? How the column sizes are decided? We saw the column dimensions and all. We saw the beam sizes. We saw the depth of the footing. But how do you decide the column size, the beam sizes? We'll try to see that, right? So you might have seen these are the beams, right? So these are the beams and these are my columns. But what should be the breadth of my beam? What should be the depth of my beam? I don't know how to decide, right? So for that we have certain thumb rules, and through that we usually try to do that. Okay. So usually the thumb rule is that L by 10 to L by 12. That means what is L? L is a clear span. So what is exactly a clear span? For example, if this is my column, okay, let me do it in this way. So this is a column what I have, and this is another column what I have. So the distance from this center to this center, from this, okay, from here to here, this is called as my clear span. Whatever is your clear span, that is taken as L. So what we are supposed to do, the distance between the two columns, will divide it by 10 or up to 12 we can say. Now let us consider this particular thing, whatever I have, it's a 5-meter length. I'll say this is 5 meter. So what is my thumb rule? My thumb rule will be 5 meter. This should be in mm. So 5 meter in terms of mm comes out to be 5,000. So I'll do, yeah, 5,000 divided by 10. Okay, L by 10 is 5,000 divided by 10. I can go up to L by 12, 5,000 divided by 12. So try to do it manually. If you have a calculator with you, please try to do this. What you're supposed to do? Give me a minute. Yeah, do it. And yeah. So you can do these calculations and let me know what is the answer you're going to get. So let me do it manually here. Yeah. So 5,000 divided by 10 comes out to be 500 mm. Okay. And if I say 5,000 divided by 12, okay, it's not minus. Okay. It is L by 10 to L by 12. And 5,000 divided by 12 comes out to be 416 mm. So now I got an idea that I can keep the depth of my beam in between 416 to 500. So what is the best size I'm supposed to take? I can go with 450 because 450 is the standard size we go. You can even take 425, but we'll go with 450. So now I'll say I'll go with 450 mm is my depth of my beam. You're getting my point? So this is how we decide. Now again, this is not a final one. It depends on what is the load coming and all. But initially to start with my designing, I need a tentative size, right? So that is why I go with 450 mm. Very simple. Yeah. So if you don't want to follow this, there's another simple thumb rule. For every 1 meter of a length, you can take 100 mm is the depth of your beam. So what do I mean by that? So for every 1 meter, you can take 100 mm depth of your beam. So what is this? It is 5 meter. For every 1 meter, if it is 100 mm, for 5 meter, how much it is? 500 mm. So you can take 500 mm as your depth of your beam, and then you have to do the trial and error. Will try to do in the ETABS software whenever we are designing. This much is understood. Very simple. Now take a kind of assignment. Tell me, I'll say my distance is 4.65 meter. Yeah. So for this, you tell me what will be the depth of the beam you're going to keep. That this 4.65 is my distance of this. Okay. I'll make this as 4.6. Distance between two columns, 4.65. Now you tell me what will be your depth of your beam. It's very simple. 4.65. I'll take it as 4650. 4650. I'll divide it by 10. Okay. I'm getting 465. I'm getting 465. And again 4650 divided by 12. Okay. So I'm getting 387 mm. 387 mm, and this is 465 mm. Now you're free to choose any size. So your value should lie in between 387 to 465. Again, you can take 450, but instead of taking 450, you can take average of that. So we'll go with 425. 425 is a very decent size I can have. So I'll go with 425 mm is my depth of the beam. Again, it is not a final size, but a tentative one. So maybe the final will come out somewhere close to this, or there's every chance this may be our final. It depends unless we try to design that. So how the designing has to be done, that I'll be taking up in the upcoming lectures. Pretty simple. Yeah. Now coming to the width of my beam. Depth I've decided. What about the width of my beam? So for the width, you can usually go with the thickness of a brick, because if you see, this is my construction. We do a brickwork or a block work here, right? And the thickness of a brick will be usually a 9-inch, which comes out to be 230 mm. Or sometimes we use 8 inches block, which comes out to be 200 mm. So usually what we do, whatever is my brick size or a block size, that will be my width of my beam. So if you're using a 9-inch block, or I mean, if you're using a 9-inch brick, then the width of your beam will be 230 mm. And if you're using an 8-inch block, the width of your beam will be 200 mm. So usually I've written it here. Try to keep minimum 200 mm is a minimum width you're supposed to keep. You can even keep it as 230 mm also. Okay, that is what you're supposed to do. Other than that, there is one more thumb rule. Whatever is a width by depth ratio, it should lie in between 0.4 to 0.45 according to Indian Standard 13920 detailing code book. You can follow that. Otherwise, if you see most of the construction, no, I'll show you all those things. Also, you try to see the drawings what I've shown you. We usually take 9-inch by 9-inch is the width of my beam. That's pretty simple. So to put it in a better way, let me quickly show you that. I'll show you a few of the drawings. Yeah. So let me go with the one of this drawing. Okay, this is for the column, right? I should go for the beam. Okay, I think give me a minute. I'll show you the beam one. Yeah, so you can see this. This is a plinth beam shuttering details and the ground floor roof beam details. So if you come here, you see the size. I mean the width. The width is 9 inches. What is 9 inch? 230 mm. Pretty simple. So whenever you look into any of the beam, you see everywhere it is 9 inch. So it is 9 inch. This is also 9 inch, 9 inch, 9 inch. Everywhere it is 9 inch. Good. In the same way, I'll show you one more thing. See here, what is given? Plinth beam 1. What is the width? 10 inches. What is the width? 10 inches. What is 10 inches? 10 inches comes out to be how much? Roughly, uh yeah, so 10 inches comes out with 250 mm. So here they have gone with the 250 mm. 250 you can go, but I would rather say go with 230 mm. That is the best size to have, because 10 inches, so 1 inch is 25 mm. 25 to 10 comes out to be 250 mm. So 250 mm is the width what they have given, but the chance of giving 10 inch is very less. We usually go with either 9 inch. 9 inch is the only typical size what we go with. Okay, yeah, great. So maybe they have given a 10 inch here, maybe because of the requirement, but 9 inch is a good size to be given for the beam width. Okay, that is what you're supposed to follow. Great. Yeah. So again, if I come here, this is one more drawing what I have. Let me show you the beam schedule what has been given here. Yeah. So you can see it here. Look at the beam name and the beam size. Okay, they have given GB1 means ground beam 1. Look at the size. It is 200 mm. 200 mm in the sense it's a 8 inch. So you can see everywhere it is 200 mm. So that is a typical breadth what you're supposed to give. And the depth, whatever you have, we have that formula. L by 10 by L by 12. Pretty simple. And this particular plan, right? So in this way, they have given the breadth of all the beam. So I hope you have enjoyed this lecture up to here. you got an idea like how the depth and how the breadth of my beam has to be fixed. Okay, so here we'll try to see how the designing is done. Okay, so you remember this plan which I had taken and I had explained you, right? How this plan is worked out. Like we had this, elevator here, there's a veranda here, a bedroom here. For the same plan, this is the architectural plan. Here you don't get about the column, the beam, the slab, the reinforcement details for the footing and all. So as a structural consultant, what we try to do, we try to create a model for this. So there are softwares like ETABS, StatPro and all. So this is one of a model what I've created. So whatever building we are seeing it here, right? So whatever building you're seeing it here, let me show that 1 second to you. This particular building, whatever we are seeing, a similar model, okay, a similar building we have created through this software. Okay, you can see that it's the same thing. Let me try to show it in this way. Yeah, what I can do is I'll go with this way. Yeah, okay, it's not possible. Yeah, now it's possible, I guess. Yeah, can you see the same thing? Whatever plan I'm showing it here, you can see the shape how it has come. Okay, in this way the same thing I've created here. Okay, now you got an idea. So now what we do when we create such models, we try to apply the loads and all, like what is the load coming on that. Okay, so first we'll see about the beam and the column sizes. Now you can see all these are my column. This portion, if I try to zoom in, this is my column, this is my column, and this is my beam, this is my beam, and this is a gray color, whatever you can see, that is a slab. So if I show you it in the 3D model, you can get a good idea. See, these are my columns. Okay, the vertical part are my columns. The gray color is my slab. Now we'll see how we have given the this thing, that is a beam and the column size. I'll go to define option and let me go to the section property and the frame sections. So can you see the dimensions of the beam given? 200 by 300, 200 by 350, 200 by 400, 200 by 500. And column, C stand for column, 200 by 200, 200 by 300, 200 by 350, 200 by 400, 200 by 500. Whatever standard dimensions I had explained, the same thing we have done an input here. Of course, we have taken a lot of dimensions. That is for trial and error method. We don't know which dimension will hold good here. So we input everything and then we do a trial and error method to check which beam and the column is going to take care of my load and there won't be any failure of the building. You're getting my point? Along with that, all these are my slab. So if I right click on the slab and if I go to the load part, okay, it's a shell load what they have put, not an issue. So what I'm basically trying to tell is this is my slab, isn't it? On the slab we have different load coming. One is a live load and a dead load. So we have certain code book for that. IS 875 part 1 is for the dead load, part 2 is for the live load. So let me even explain you that also so that we get an idea. Wait, give me a minute, I'll show you that. Yeah. So this is a code book what we have, Indian Standard 875 Part 2. It is for the imposed load. So we have different category of buildings, like we have residential building, we have commercial, we have industrial buildings and all. So in this code book, it will ask us what is the building you're looking for. For example, see here, if you are putting a residential building and if you have a rooms and a kitchen, then you're supposed to put a live load of 2 kilonewton. If you're putting a toilet in the bathroom, you're supposed to take 2 kilonewton per square meter as your uh, live load. Okay. Suppose if it is a corridor portion, you can take it as 1.5. If it's a balcony, you can take 3 kilonewton per square meter. Similarly, if you're constructing a hotel, boarding houses, lodging and all, then in the living room, you're supposed to take 2 kilonewton per square meter. Storeroom, it is 5. Office room, it is 2.5 and so on. You're getting my point? So the load, whatever we are going to pick and we are going to design, that will be taken care from here. I mean, it will be taken from here. If you're putting educational buildings, in the classroom, you're supposed to keep a live load of 3 kilonewton. In the projection room, you're supposed to keep it 5 and all. So in this particular building, we'll try to see what is the load I've applied. I'll go to the shell part and I'll go to the live load part and I'll say apply. So can you see here a live load? Okay, ground floor it is. Yeah. So can you see it here? 2 everywhere, 2 and 3 is seen because since it's a residential building, most part of the building we have bedrooms And in the bedrooms, according to my code book, I'm supposed to take, if I go, okay, where is this part? Yeah. So here in the bedroom, it is written all rooms I'm supposed to take 2 kilonewton. So that is why in the model also you can see most of the part we have 2. And these are few bathroom parts. Even in the bathroom it is mentioned, if I come here, so in the toilet and bathroom you are supposed to take 2. And wherever there is a corridor, passages, staircase part, you're supposed to take 3 kilonewton, and balcony is 3 kilonewton. So that is the reason you can see. See, if this is my corridor portion and all, it is 3 here. It is 3 in the corridor. This is corridor, isn't it? If this is a cutout, what I have, you'll be having a staircase from here. This is corridor. This is corridor, right? So I have taken 3 kilonewton. So from where all these things are taken, it is taken from certain code books. You're getting my point? So in this way, we try to apply all these loads and all. Okay. Once we try to apply all this load, you have to do a model and all, which is not covered here. Uh, Maybe in future I may bring a course on designing of all these things so that you get a better idea. Okay, great. Yeah, so this is how you're supposed to put. Once we put all the loads and all, we try to do an analysis. We try to run the model. Okay, let me run the model. Yeah, so it is analyzing all these things. Okay, it is going to do all the structure analysis calculation like bending moment, shear force and all. And finally I'll go for design, concrete frame design, and start design check. And now I'm going to design, I'm going to check whether the beam sizes and the column sizes, whatever I have given, whether it is sufficient enough to take care of the load coming or not. So I'll click here. You can see all my columns which are pink in color. So if it is pink in color, that means my columns are passed. Suppose in somewhere, if any red color was coming, so I think there is one red color here. No, everywhere it is pink. So everywhere it is pink. If suppose anywhere the red color was coming, that means my column has failed there. So in that case, I need to change the size of that. Right? You're getting my point. So let me make that changes here. I'll do one thing so that we get an idea. I'll select this column, this column. Not in one story. I'll go with all story option. I'll select this column, this column, this column, this and this. Okay. I'll go to assign. I'll go to frame and then the section property. And I'll give a section of a small size. Let us say I'll go with 200 by 200. I know that it's definitely going to fail because since it's an interior column, 200 by 200 is a pretty small size, which the column is not going to pass. And now let me run the analysis and let me see now what is going to happen. And definitely there will be a failure of this column, and you can see that in the red color. We'll see that. So when such failure happens, what I do, I try to increase the size of the column. Instead of giving 200 by 200, I go with 200 by 450, and then I try to do the analysis. So you're getting my point? So that is how the structure designing will be done. And through that, finally we are going to give the beam column size and all. And definitely you can see it here, it has come red in color. Why? Because 200 by 200 is a pretty small size, and these are your interior column. More load will be coming because this particular column is subjected to the slab load from here, slab load from here, slab load from here, slab load from here. Like if I want to put it in a better way, this particular column is subjected load from all these sides. Okay, and we need to give a bigger size. Since that is the reason I told you, interior columns your sizes will be more. And you can see all the failure here, it's red in color. Even it is red in color here. Okay, here there is no problem. Okay, here there is no problem. Only the problem was in these two columns. Maybe I'll go to the next floor. Okay, here also there is no problem. Okay, there is no problem, but the failure is happening on in the ground floor. But it doesn't make any sense. You're supposed to change the column size here. Getting my point? So in this way, I explained you for the column. Similarly, if I change the beam size also, the same thing is going to happen. Beams are going to fail. Then again, you modify the beam size. Instead of 9 inch by 15 inch, you go with 9 inch by 18 inch. You go with 9 inch by 21 inches. That is how you try to play with the softwares, and your judgment is also required. And that is how you try to design. So once all these things are done, I'll show you the bending moment and the shear force diagram for this. I'll click here and I'll say I want to see a moment, and you can see all these are my bending moment and shear force. So through this, I get an idea. what is my negative bending moment here. So this particular portion I'm showing for this beam. So I'm getting this negative here. Then I have sagging bending moment, and this is negative. You remember, right? The bending moment what I had plotted at the time of beam explanation, negative, positive, and negative. So same you can see it here. Practically through a software we get something like this, and based on that only we try to design all those beam, the column, steel, and all. Okay. Similarly, I'll show you the shear force diagram. I'll go here again. Yeah, yeah. I'll go with the shear 2 and I'll say apply. So now can you see the shear force diagram? I'll click on right click. See, this is shear force, the maximum shear force at the support, the maximum shear force at the support, and then it's going to vary in this way. You're getting my point? So this is how you're supposed to understand all these things. And after this, once we do all these things, we'll do all the manual calculations. We'll be having a lot of uh, our this thing, Excel sheets and all. We try to input all the values in the Excel sheets, and finally we come out with such kind of designs. We come out with such kind of designs. I'll show you the design part. Yeah, we'll be preparing the AutoCAD drawings in this way. All these drawings will be prepared. Like this is F7 footing, this is F7 footing, F8, F2, F5, F5, and you can see all these are reinforcement. We understood, right? F1 footing, F2, F3, F4, F5, F6, F7, F8, F9. What is the length of that? What is the breadth of that? What is the depth of that? You're getting my point? And what is the reinforcement coming and all? So all these things will be decided based on this ETABS model. So in this way, we try to take care of all these values and all. Okay. Yeah. So I hope you have got an idea regarding how these designs will be done and all. Maybe in the next lecture, I'll take one more lecture and I'll explain you how these values are to be put in the Excel sheet. And from there, how we take the value and how we decide all this column and beam size. Now you got an idea. Like from here only, we have to take everything. But again, this is not the final thing. We usually take the values from here. Then we'll see how the slab thickness has to be determined. So whenever we decide the slab thickness, there are two factors. One is based on strength. Second is based on deflection point of view, which we call it as a serviceability limit from structural point of view. Forget about that. Now come to this part. Okay. So let us consider this is my slab. So this is a breadth of my slab. I mean, yeah, this is my breadth of the slab and this is the length of my slab. Or I can say this is my shorter span and this is my longer span. So if your shorter span is up to 3.5 meter, that means if this distance of mine, if this distance of mine is up to 3.5 meter, yeah, if this distance of mine is up to 3.5 meter, the slab thickness what I can take is 125 mm. Okay. And if my shorter span is again, it doesn't matter what is the long span, only the shorter span we are concerned with. If your shorter span is up to 4.5 meter, 4.5 meter, up to 5 meter, 4 to 5 meter, you can go with the thickness of your slab as 150 mm. And if your slab span, shorter span is greater than 5 meter, you can go in between 175 to 200 mm. That means either you can take 175 or 200 mm depending on the load coming on that. But these are the minimum sizes what you're supposed to do. And we can make use of this slab thickness so that we can design any project. So if you observe, anyhow, we'll take that as a example and we'll try to see that. So now the question is that why I'm going in the multiple of 25? After 125, why it is 150? The reason is that 1 inch is 25 mm. And whatever tape it is available, it's a feet and inches. We have 1 inch, 2 inch, 3 inch. So it is easy for the person on the side to do the measurement. If I say 6.5 inch of a slab, it's pretty difficult for him. 4 inch, 5 inch is a round figure. And when I say 4 inch, it is 120, it is 100 mm. When I say 5 inch, it is 125 mm. If I say 6 inch, it is 150 mm. And if I say 130 mm, in mm it is easy for me, right? 130 mm with a tape you can measure. But if you're using a feet and inches tape, 130 mm comes out to be roughly how much? Uh, Somewhere close to 5 feet, 5 feet 3, 5 feet 1 inch or something like that. So it's very difficult for you to measure 5 feet 1 inch on the side. 140 mm you can measure, 130 mm you can measure. But when it comes to feet and inches, it's difficult. So we go with the multiple of 25. So 125, 150, 175 and 200. The same thing I've written it here. Pretty simple. Now, if you observe all the drawings, if you observe the drawings what I had shown you, we had gone with the slab thickness of 5 inches, right? Either it was 5 inch or 6 inch. So 5 inch comes out to be 125 mm, 6 inch comes out to be 150 mm. And for almost all the construction, 5-inch or a 6-inch is a minimum size of a slab that we go. We don't go with the 7-inch or 8-inch slab unless it's a huge load coming on that. Otherwise, 5-inch and 6-inch is a pretty decent size of a slab that we can use. Good, great. Now we'll understand one more thing. That is, previously we understood for the column, right? Now we'll try to understand for the plinth beam and the slab, how we can take the standard sizes. So for the plinth beam, you can, if your span is up to 15 feet, that is the distance between the two column, if it is 15 feet, you can go with a beam size of 230 by 375 mm. If your spans are more than 15 feet, you can go with a beam size of 230 by 450 mm. Okay. Again, you can see it's 230 mm since it's a 9-inch wall what we construct. Now for the floor beams, that is your first floor, second floor, ground floor beams and all. If your span is up to 15 feet, you can go with 230 by 425 mm column. Okay. And also you can, if your span is between 15 feet to 20 feet, you can go with 230 by 500 mm. Okay. Forget about this part. This is not required. This is because when I say slab thickness, it is inclusive of the, whenever I say beam depth, it is inclusive of your slab thickness also. So that is why these people have made it like a 300 plus 125 comes out to be 425. That means 300 mm is your is the depth of your beam plus 125 is the slab thickness. Together it is called as 425. So we'll do one thing. I'll take it out. This is not required. Let me strike it out. Okay. Now you understood 230 by 425 mm if it is up to 15 feet, and 230 by 500 mm up to 15 to 20 feet. Again, these are again all thumb rules. Okay. You can even apply that formula of L by 10 by L by 12. That is also good. You can even go with this. Pretty simple. And for the slab thickness, they have given one more thumb rule. If your slab panel is in between 13 feet to 16 feet, shorter span 13 feet, longer is 16 feet, or in between that, you can go with a 5-inch thickness, which is 125. And if your panel is greater than 13 feet by 16 feet, maybe if it is a 14 feet by 17 feet, so it is greater than 13 feet and 16 feet, you can go with 155 mm, 150 thick, that is a 6-inch. So whatever may be the condition, go with either 5-inch or 6-inch slab, and that is enough. Okay, for any of the construction, maybe a commercial, residential, we don't go beyond 6-inch and all. For slab, 150 is enough to take care of the load coming on that. Good, great. So I hope with this I've explained you all the things like how to decide the beam, column, and the slab thickness, and we have understood everything. So in the next lecture, I'll quickly show you how actually these things are designed with the help of a ETABS software. We'll not be doing complete thing, but we'll try to get an idea so that you get how all these things are practically implemented through a software, and from there, how. So we'll see how the column size are to be decided. Now, to decide any column size, we need to follow one rule, that is width by depth ratio, whatever we have, no, it should be either greater or equal to 0.5. That is according to IS 13920. Along with that, I'll be telling you certain standard dimensions, but you can follow this. So what exactly is this? What is this width by depth ratio? That means if I take any column, let us say I'm taking a size of column which is 300 is the breadth of the column, and when I say depth, this is not the depth. Okay, see, when I say 300 mm, this is my 300 mm. And when I say 500 mm, that is called as depth. So this is called as depth of the column. And this is called height of the column. Don't, get confused. When I say depth, it means the vertical portion. For the column, when I say depth, so this becomes my depth. Okay. The longer one becomes my depth and the shorter one becomes my width. Pretty simple. Yeah. Now we'll apply that width by depth ratio. If it is greater or equal to 0.45, only then we should go with this particular size of a column. So now let us say what is width. Width is 300 and depth is 500. Try to do the calculation. 300 by 500, I'm getting 0.6, and 0.6 is greater or equal to 0.45, obviously. So I can go with this dimension of 300 by 500. Now let us say I'll take one more dimension, which is 300 by 900. Now again, 300 divided by 900, if I do, I'm getting 0.33. But 0.33 is less than 0.45. Agree with me? So that means I cannot go with this column. I mean, when I say I cannot go, this dimension is not a good dimension according to our Indian standard 13920 code book. So, but again, you don't have to always do this calculation. I'll be giving you certain column and the beam sizes. You can always take that as a ready sizes and you can go with the calculation. So the best practice is that for the beam, for the column, if it is a residential building, you can go with 230 mm is your minimum breadth. And if it's for the commercial building, go with 300 mm your 300 mm as your minimum breadth of your column. Got pretty simple. Now what I'll be doing, I'll be showing you certain dimensions so that we get an idea. Okay, come. Yeah. So always remember this. We'll start with this. So 9 inch by 12 inch is a minimum column size that you're supposed to give. Whatever may be your structure, even if it's a ground floor structure, doesn't matter to me. You have to go with 9 inch by 12 inch. Then what is 9 inch by 12 inch? It is 230 by 300 mm. Pretty simple because 1 inch is 25 mm. So 9 into 25 comes out to be 230. 12 into 25 comes out to be 300 mm. Next, if this column is failing, you can go with 9 inch by 15 inch. Next standard size. We don't have a size of 9 inch by 13 inch. We go with 9 inch by 15 inch. Then we have 9 inch by 18 inch. Then I can go with 9 inch by 21 inch. Then I can go with 9 inch by 24 inch. These are standard dimensions what we can adopt. Now, if you don't want to go with 9 inches, you can go with 12 inches also. So 12 inches comes out to be how much? 300 mm. So especially in case of commercial building, we go with 300 mm as my breadth of my column. So again, you can start with 12 inch by 18 inch for the commercial building. You can go with 12 inch by 21 inch. You can go with 12 inch by 24 inch. Even you can go with 12 inch by 27 inches. Okay, these are the standard dimensions. But whenever you construct a house, if it is a small ground floor structure, these two sizes, whatever are mentioned, no, 9 inch by 12 inch and yeah, this 9 inch by 12 inch and 9 inch by 15 inch is pretty sufficient. If you're going for a G+1 and a G+2, there may be a chance you need to go with this combination also, that is 9 inch by 18 inch. Very simple. And then if it is a G+4, 5 and all, you may have to try with these combinations. Now, whenever you do any planning of a house, usually if this is my house, okay, if this is my house plan, and let us put certain columns here. I'm going to put one column here. This is my another column. I'll put one more column here. Maybe another column here. I'll go with this orientation now. With this orientation now. And one more column here. One more column here. Column here. Column here. Let us say I'm putting some more columns here. Okay. I'm putting certain columns. So usually what happens, the columns which are in the interior, the column which are inside, that is these columns, this particular columns, these columns will be subjected to more load because since it is in the interior part, it will be getting the load of a slab from all the four direction. So in this case, there's every chance that you have to give a bigger size of a column. Now let us say I have the three sizes to be to choose: 9 inch by 12 inch, 9 inch by 15, and 9 inch by 18. So these four columns, I'll go with 9 inch by 18 inch since they're in the middle portion and they're subjected to more load. I need to give a bigger dimension, right? Agree with me? So I'll go with 9 inch by 18 inch. So this I'll go with 9 inch by 18 inch. And all my exterior columns, these columns, since less load is coming then, I can go with 9 inch by 12 inch. Again, you need to do a proper analysis, but as a rough thumb rule, you can give all your outer column with 9 inch by 12 inch. And then we have another, this two column, agree with me? This particular column, this two column, and let us say this two column. Let us consider this column. I'll go with 9 inch by 15 inch. This and this 9 inch by 15 inch. Why? Compared to this four column, the load coming on this two column is less, right? Here from all the four sides, the load will come. Here also it will come, but let us say the load coming is comparatively less. Again, it depends on the sizes of the distance between the two column, the length of your slab and all. Let us consider. So what I'll do, I'll provide 9 inch by 15 inch column for this. Pretty simple. So in this way, we try to do the analysis, and these are the standard column size what we adopt. Now you have another few thumb rules. So what you're supposed to do, if you're putting up a ground floor structure, which is ground floor plus two floor, and your spans are not more than 15 to 18 feet. When I say span, the distance between the two column, if it is not more than 15 feet to 18 feet, you can go with 9 inch by 12 inch and you can go with 9 inch by 15 inch. If you're putting from G+2 to G+4 floor, and if your spans are not more than 15 to 18 feet, you can go with 9 inch by 15 inch and 9 inch by 18 inch. So two combination we are going to do. Again, you know the logic. This 9 inch by 18 inch will be exactly used in the interior places in the middle, and all the periphery portion you can go with 9 inch by 15 inch. If you're putting up a G+4 to G+6 floor structure, you can go with 9 inch by 18 inch. This is a minimum size you're supposed to use. And even you can make a combination of 9 inch by 21 inch. If you're going from G+6 to G+9 floor, you can go with 12 inch by 18 inch. You can go with 12 inch by 21 inch, and even 12 inch by 24 inch, and 15 inch by 21 inch. So now you play with a lot of combinations wherever the more load is coming, you go with the higher size, and wherever the less load is coming, you go with the smaller size. Pretty simple. Yeah. So with this understanding, I'll take you to a few of the drawings so that we can verify those sizes. Okay, and all these are the buildings which has already been constructed. So let me go with this particular building. What is the yeah, yeah, just concentrate here. What is written? This particular structure is designed for ground plus 2 upper floor only. That is ground floor plus 1 and plus 2. And now you see the column sizes here. So they have gone with 9" by 15", 9" by 18, 9" by 18, 9" by 9" they have used, and 9" by 9". So this may be a pretty this yeah, okay, they have used it here. C3 column. Now we'll try to understand. See, this C2, C3 and C3A column both are 9" by 9", and see where these columns are located. So you can see here my C3 column is here, C3A column is here, and C2A column is here. So since they are in the outer side, less amount of load is coming. You can see maybe it's a kind of opening. We'll see what exactly. Yeah, maybe it's a kind of opening or a porch area. Since it's a porch area and all, you don't have much load coming on that. Since the load coming itself is less, we can go with the minimum column size, which is 9" by 9". Now, which is a bigger size here? So the bigger size is 9" by 18", right? And for C2 and C2A. Now let me see where is my C2 column coming exactly, right? So in this entire plan, where is my center column, which is my center portion? Do you agree that this is my center portion? That means these 4 columns will be subjected to more load. That means I need to give a bigger size of a column here. And now you see what is happening. So 9" by 18", the name of the column is C2. You can see the C2 name here. Let me take it out. Yeah. Can you see the C2 name here? Agree with me? C2, C2 and C2. Why? The name C2 has come because exactly the load, more load was coming. So we have gone with a 9" by 18". We did not go with 9" by 9" here. 9" by 9" is a pretty small size of a column, so that it cannot bear the load of a G plus 2. So we went with C2 column, that is 9" by 18". Other than that, wherever C2A is there, so where may be a C2A? So C2A, I cannot see C2A anywhere. Maybe mistakenly they have written this C2A here. Otherwise, yeah, C2A is here. Okay, this particular column. So again, this is again your 9" by 18". Maybe in this portion, all the slab is coming from this side and this side. So that is why they have gone with 9" by 18". But the logic you have understood why the interior columns will be of bigger size. Pretty simple. Now let me go with other columns. And these columns we directly have a column size. Just try to understand the column size. Okay. So 230 by 450, which is a 9" by 9" by 18" column. 230 by 450, 230 by 450, 230 by 450. It's a circular column of 450 mm, and this is again 230 by 500, 230 by 500. So you're getting my point. Similarly, let me go with this particular building. Again, you see the size of the column. So here the size of the column is 10 inches. 10" by 1 feet 6 inch, 10" by 1 feet 6 inch, 10 feet by 1 feet 6 inch, 10 feet by 1 feet 6 inch, 10 feet by 1 feet 6 inch. So 10 feet, so not 10 feet, sorry for that, it's 10 inches, okay? So 10 inches comes out to be 250 mm, and 1 feet 6 inch comes out to be 450 mm. So the column sizes what they have used is 200, not 200, 250, okay? 250 by 450 mm. So again, this is the column size what they use. So whatever standard column we saw, no, the same has been implemented practically on the side. Let me go with one more drawing. Yeah, for this drawing, let me see what is the column size that has been put. Yeah, yeah. So here you can see it here. What is the size? 200 by 300, 200 by 350, and then 200 by 350, 200 by 350, 200 by 500, 200 by 500. Again, these are the standard sizes what we are going to use. And same thing we had seen through a PPT, and same thing I've explained you here. Okay. Yeah, great. So yeah, it's a 230 by 300 mm. And what is the dimension we took it here? Yeah, 300, because it's a commercial. Yeah, because it depends, because they could have taken it 230 also. Maybe the brick size what is available in that area, it might be a they're planning to construct this with the help of a block. So if it is a block, it's a 200 mm thickness, not 230. So they have gone 200. If 230 was the case, they would have taken 230, which is 9-inch by 12-inch column. Pretty simple. Great. So here we'll see how the designing is done. Already in the previous lecture, we understood about the ETABS model, how the load application is done and all those things. Okay. Now, what we are going to do, I'll take you to the Excel sheet. So we prepare Excel sheet something like this. This is for the footing. Okay. So let us consider I'm putting a load on the footing, which is, let us say, 1000 kilonewton. Okay. So accordingly, it is asking me for the moment in X and Y direction. If it is a small footing, this moment is of not significant quantity. If it is, then we need to do. Now again, from where I get all these things, again I'll tell you. So when you do the analysis on the ETABS software, you have to go to the base. I'll go to the base plan. Okay. And here we have these options called as tabulated and apply. So can you see this thing? FX, FX, FX and all. All these are the load which is coming on your footing. It's a column load coming on your footing. It's a reaction what we get there. Okay. So whatever we are getting here, right? That same thing we need to input. You're getting my point? Like 254 kilonewton, 271 kilonewton, 654, then 540, then we have 362, 327 and all. Okay, you're getting my point? Again, all these things are delted it in my basic course of construction methodology. But here, let me quickly go through that. I've explained that in a more detailed way there. Okay. Yeah. So you're getting my point. So I'll take one value from here, maybe the higher one. I'll go with 654. I'll go with this 719. This is bigger, right? So 719. So what I do, I go to my Excel sheet. I'll say my load is 719 kilonewton. Okay. So based on that, what is MUX? It's a pretty small quantity. Let me make it as like 5 and 5. Okay. Again, I'll show you that in the software also. If I go here, I have to tick on this MX and MY. I'll say apply. Can you see the same value? MX and MY coming here. MX and MY is coming. Now this is it's like minus 1.9, minus 8. It's a pretty small quantity. Of course, minus 13 is a good quantity, but 1, 2 is a pretty small quantity. If you want, you can input, but again, you need to do careful analysis to that. But for the moment, we'll not go with that. Okay. Now coming on the column size. Now what is a column coming here? This is a reaction coming here, just 719. There might be a column which is coming on that. So what is the size of the column? We are gone with the 300 by 450 column everywhere. Let us consider. So I'm supposed to input here 300 by 450. I'll input 300 by 450. Gone. Now SBC we are supposed to give. SBC stands for safe bearing capacity of the soil, which is given by a geotech consultant. Let us say he has given 180. Okay. Now for this particular load and for this particular column, you need to provide 2.93 mm square of the area. Okay. Not mm square, meter square of the area. 2.93. So I'm going to decide now what should be my length and breadth. So let me start with 1.5. I'll put 1.5 meter as my length and I'll put 1.5 meter as my breadth. Okay. So my requirement is 2.93 meter square. By providing 1.5 by 1.5, I'm providing 2.25 meter square of my footing size. I mean footing area. My requirement was 2.93. So that is why you can see change the footing dimension. That means this dimension if you give, it's not sufficient to take care of the load coming on that. So you have two options now. Either you keep length, either you keep the breadth as it is and you can increase the length. Instead of 1.5, let me go with 2 meter. So by giving 2 meter by 1.5 meter, my requirement was 2.93. 2.93. I'm giving this thing, I'm getting 3 meter square, but whereas your SPC is 180 kilonewton per square meter. That is the SPC of your soil. But your net upward pressure is more than that, which is 184. That is why it's telling change the footing dimension. So what I can do, now I'll go with 2 meter by 2 meter, or let us go with 1.75. So now it is okay. You see, my SBC actually is 180. By providing 2 meter by 1.75 meter of a footing size, I'm giving 3.5 meter square of the area, which is more than my area required. This is area provided. You see the net upward pressure. It is less than SBC. If you had done the manual calculations, we had always written, hence it is less than SBC, right? So my 157 is less than 180. So my footing size is okay. Now you still have a liberty. You still have an advantage of decreasing the size because this thing SBC is 180. You are giving only up to 157. You are having a margin of around 23 kilonewton. So what you can do, instead of making it big uneconomical, no, what I can do is I'll go with 1.75 by 1.75. Yeah. Now you see 1.75 by 1.75. You are giving 3.06, which is less than 2.93. And now you see the net upward pressure. It's almost equal. So if you want, you can go with this. Else, try to have a buffer of 5. That means what 175 is, this is a good size to have. Else what you can do is, again, you need to play with this. So I can even make this as 1.85. Yeah, this is good. But again, the footing doesn't look that good, 1.85 by 1.75, but still we go with this. 1.85 is my length, 1.75 is my breadth. And you see the net upward pressure, which is 170, less than 180, we're having a buffer of 10, and it is good, not an issue. You can go up to 175, 176, even close to 178. The reason is that this is not the actual SPC of the soil. This is not the actual SPC of the soil. The actual SPC of the soil is almost 3 to 4 times of this, what I'm trying to tell. 180 kilonewton per square meter is not the actual SPC of your soil. It is almost 3 to 4 times. That means your real SPC on the soil was somewhere close to 540 to 650, 700. But since soil is, we cannot predict the nature of the soil. Concrete, you can predict the nature. We can assume that concrete is homogeneous, and with the proper mixing, control mix and all, we can have a proper, we can have a proper, what you call, uh, analysis on the concrete. You can trust the concrete. But whereas soil, you can never trust. The reason is that soil is unpredictable. Whatever soil is available in your plot may not, in a nearby plot, the same soil is not available. For every 1 meter length and every 1 meter depth, your soil nature is going to change. So that is why when a geotech consultant gives you all this SPC and all, he tries to be more safe. So even though your actual requirement SPC on the soil was somewhere close to 540 or 650, he's going to apply a factor of safety of nearly 3 to 4 times. So that is why we are getting 180. So that is why we can go up to this 175, 180, not an issue. Got it? So why that much factor of safety? Soil is unpredictable. Soil is like a small baby. The baby which comes to you, I mean, whenever you hold any baby, it may be happy with you, right? It may not cry. Today it may not cry. Tomorrow it may cry with you. So you cannot predict the nature of a baby, right? In the same way, you cannot predict the nature of a soil. Every 1 meter length and every 1 meter depth, the nature is going to change. So that is why careful analysis has to be done. So that is why we put a lot of factor of safety. Very simple. Chalo, this is understood. Now come to the length is done, breadth is done. I need to decide the depth of my footing, isn't it? So for that, what I'll do, I'll directly come here. Overall depth, I'll start with 300 mm. So 300 mm will be depth of my footing. Then I need to check here. So I'm getting a warning, increase the depth, increase the depth, increase the depth. We have 3 conditions to check. One way, I mean, what is that? Yeah, one way shear along the X direction, one way shear along the Y direction, and two-way shear is called as your punching shear. That means whatever column I have, if this is my footing and if this is my column, when the load comes, this column should not punch my footing. Okay. If it is punching, it is called as punching failure, or it is called as two-way shear. Okay. So that is why, as far as possible, I should make sure that my footing depth is strong enough so that this column will not punch. If your footing depth is not thick, if it is a small thickness, if you're keeping, then obviously due to the column load, it is going to pierce this. I don't want that to happen. Pretty simple. So that is why it is giving us the warning that increase the depth, increase the depth, and increase the depth. Okay. So what we will do, instead of 300, I'll go with 350. You can go even with 400, but we'll go with a multiple of 25. With a multiple of 50, I'll go with 350 now. Let me check. Again, I'm getting a warning. Yeah, you can see one-way shear check is okay. Two-way shear check is okay. But in one-way shear along the X direction, it is failing. So instead of 350, let me go with 400 now. I think this should work out. No, still it's failing. Increase depth. These things are okay. So I think we should go with 450. Yeah, now you can see. You can even try with 425. If you want to make it economical, go with 425. And 425, yeah, one-way shear check is okay. One-way shear check is along is okay, and two-way shear check is okay. Pretty simple. So what actually happening here? See, the tau v what is allowable, the 𝗖C what is yeah, the 𝗖C what is allowable is 0.298. So whatever I'm providing, that is 0.283. So my 0.283 is less than 0.298. That is why it's coming safe. In the earlier case, now I'll go back. I'll put here 400. Now you see the difference. Okay. So what is happening? Your 𝗖C allowable is 0.318. Okay. Whereas through this depth of 400, your 𝗖v is coming 0.33322. So your 0.322 is greater than 0.318. So that is why it is saying increase the depth. So that is why what we do, we go with 425. The moment I put 425, what is happening? 0.298 has 0.283 is less than 0.298. Hence, it is one-way shear check is okay. Pretty simple. So in this way, finally my footing is ready. So finally my footing is ready. So you can see it here. What is the length of my footing? The length of my footing is 1.85 meter. The breadth of my footing is 1.75 meter, and the depth is 425 meter. Okay. And what is the footing name? Let us say I'm giving the footing name as F1. The footing name is F1. Done. So I'll write it F1. The size is 1.85 by 1.75 by, what is the next part? What is the depth we have taken? The depth what we have taken is 425. So I'll make it as 425. 425. I'll write it in mm only, no problem. 425 mm. Okay. Okay. Not an issue. I'll make this meter. This I'll make in meter. Yeah. Now you are okay with this. That's it. So once you're done with this, I did for one footing. Similarly, you're supposed to do for all footing like F1, F2, F3. Then you're going to do the grouping of footing. Okay. So finally, once this is done, this is how we try to give the reinforcement. This is how you can see here. For the footing F1, the length is 6 feet 6 inch, breadth is 6 feet 6 inch, the depth is 8 inches. Here I have written in terms of meter. So for the meter, I think I need to show you one more drawing. Give me a minute. Yeah. So now you can see the difference here. Let me show that. Given you a feet and inches drawing now. I mean the meter drawing. See here. Okay. So now for F1 footing, what is the size? The given length as yeah. I'll keep it here. Okay. And this let me bring down. Okay. Just let me take to the top. Yeah. Now it's good. See, F1 footing. This is F1 footing. The length is 2050. We got 1.85. That is 1850. Breadth they got 1850. We got 1750. And depth we got 425. They got 400 mm. You're getting my point. So in this way, all the structure drawings will be prepared, and that is where we actually learned how to read all this drawing. So this is how the designing is done. Pretty simple. Now, what about this reinforcement part? That along the shorter, you're supposed to provide a 12 diameter bar at 185. Along the length, you're supposed to provide a 12 diameter bar at 205. So for that, again, on the same Excel sheet, if you had observed, we have this part here. So what is the part? It is telling us this is shorter span, this is longer span. Along the shorter, you're supposed to provide 597 mm square of the steel. Along the longer, you're supposed to provide 440 mm square of the steel. Now you have to decide whether you should go with 10 diameter or 12 diameter. So in the footing, usually we go with 10 or 12 diameter of the bar, not anything beyond that, unless there's a huge load coming. So what I do, I'll start with 16. I have an option here. I'll go with 12 diameter, and I'll provide, I'll make 12 diameter on both the sides. Okay, see, if I'm providing a 12 diameter bar along a shorter and along the longer direction at a spacing of 125, I'm giving 905 mm square of the steel. But what is my requirement? 594. Am I not giving more steel? Obviously, I'm giving more steel. So I have two options. Either to decrease the diameter of the bar or to increase the spacing. So what we do, we'll increase the spacing. 125 is a very lesser spacing what we are doing. Instead of 125, I'll go with 175 this time. Okay, I'll go with 150 now. So by giving 150, what is happening? By giving 150, it has come to 754. Still, it is greater than 594. Let me go with 200 this time. I'll go with 200. Yeah. So now you see, by providing 12 diameter bar at 200 center to center spacing, my requirement was 594. But what has happened? By providing that, I'm giving 565, and 565 is less than 594. So it's telling wrong. That means this is not possible. Now you have two options. Either you decrease the spacing from 120, from 200, you bring it to 175, or instead of 12, no, you can go with 16 diameter bar. The moment you give 16 diameter bar, it has gone to 1000, almost 2 times, not required. We are making our structure uneconomical. And 16 diameter, usually we don't go with footing. Let me keep 200, let me keep 12 diameter. I'll bring this to 175. Okay. Now you may think, why not 180, why not 190? You can do, but practically not possible. We go with the multiple of 25 because 1 feet, because what is that? 1 inch is 25 mm. Okay. So that is why we do. I'll go with 175. Now this is pretty good. 594 was my requirement. By providing a 12 diameter bar at 175 center to center spacing, I'm giving 646 mm square of a steel, which is not too much. I mean, the difference is not too much. It's in between 40 to 50, and you're okay with this. You cannot make more economical than this. And this is the final size I'm going to go. Along the shorter I have done. Now I can go with the longer. In longer, it is 443. If I do the same thing along the longer, what is happening? 443 is coming. I'm giving 646. That means almost 200 mm square more steel I've given. I can make this economical. Instead of 175, let me go with 200. Done. So 443 was my requirement. I'm giving 565 and it is okay. Now, still I can make it economical. Instead of 200, let me go with 2. Let me go with 225. If I go with 225, what is happening? Still I'm good. Like 443 was a requirement, 503 I'm given, and I'm okay with that. But 225 in the sense it comes out to be roughly 11 inches, right? If I'm not wrong, because yeah, not 11, it comes out to be, let me check it out. So 225 divided by 1 inch is 25. Yeah, it comes out to be 9 inch. So 9 inch spacing is a, it's okay. You can give a 9 inch spacing, but what will happen on shorter you are giving it 175, okay, and on longer you are giving it 225. So the person one who is doing the execution on the site, the barbender and the site engineer, will find it difficult because shorter he has to keep at 175, longer he has to keep at 225. So it's a time consuming work. So and also the BBS whatever you prepare, you need to prepare again for both. Instead of that, what we can do, I'm okay that I'll go with 175 only. I'll go with 175. Even though I'm giving little more steel, but keeping a execution point of view, I'm making it more easy from execution point of view, because this is just a drawing what I'm doing, or maybe a structure designing I'm doing. Same has to be implemented on the site. We need to keep the barbenders and the site engineer efficiency in mind. We want the project to be completed, and also when you're procuring the steel, if both are 12 diameter, it's easy for you to procure the steel. But now what I can do, instead of 12, no, I can make this 16. Let me make this 16 and let me bring the spacing to 125. Okay, no, not 125. Sorry. I'll make this as 200. Okay, it's more. No, no. I'll go with yeah. 12 is the minimum what I can do. Not possible. I'll go with 175 only. Okay, 175. Okay, you're getting my point. So all these things you should keep in mind. Just because you're making economical doesn't mean that on the site it is easy to do the execution. Site point of view also you need to think. I can do anything. I can even make this as, I'll make this even lesser. I can even make this as 200. I can even make this as 225. I'm past. I'm safer. My designing is done. I don't have issue with this. Everything is safe. Excel sheet is not giving me any warning. But execution point, those people will find it difficult. So because of that, the barbender has to properly cut the bar. The site engineer need to check again before doing the concreting whether he has used 12 diameter at 175. The spacing he has to check, and 12 diameter at 225 spacing he has to check. So it's a long process what we'll have. So that is why keeping all these things in mind, even though I'm preparing, even though I'm giving a little more steel, not an issue. Keeping execution point of view, we are okay with it. So this is the final thing. Along shorter, 12 diameter at 175, 12 diameter at 175, shorter and longer. I'll go back to the drawing, and here you can see these people have written. Here I'll do this. So according to my this thing, yeah, I'll write here. I'll provide a 12 diameter bar. 12 I'll write at how much it is, 175 center to center spacing. This is for one. Okay. Similarly, along longer also it is 12 diameter. 12 diameter at 175 center to center. None. This is how you are supposed to do it. I told you for one footing. All other footing what these people have done, no, it's similar to that. Okay. Hello, my dear students. Welcome back to the lecture. So we'll see how the column design will be done. Okay. Now again, let us say there's one column and the load coming on the column, let us consider it is 500 kilonewton. Okay. And let us say the column size is 200 and the width, the depth of the column is 450. Okay. Now what will happen accordingly? I'm going to get what is the steel that is required for this particular column of 500 kilonewton, having a size of 200 by 450. Okay. and I'll go with the M25 grade of my concrete, and that steel will be Fe 500. Okay, so I need to provide 4050 mm² of the steel. That much amount of steel is required. Now I'm going to decide like how many reinforcement I'm supposed to use, whether I should go with 25 diameter or 20 diameter or 16. So you can go with the combination of 25 and 20, or you can give all 25 diameter of the bar. It all depends up to you. So let me go with 25 diameter bar, okay, and let me go with the 6 number of bar. So if I'm providing, I'll make this 0. Wait, okay, give me a minute. Oh, here let me make it dash. Yeah. So if I'm providing a 25 diameter 6 number of bar, I'm satisfying 2945 mm² of the steel. My requirement is 4050. But here, the Excel sheet is prepared in such a way that I'm not able to give more than 6 number of bar. You can give, not an issue, but here it is made in that way, not an issue. I'll go with a combination now. So I'll go with 25 diameter 6 bar, and then I'll go with 20 diameter, okay, and this also I'll go with 6 bar. So now is it okay? My requirement was 4050. I'm giving 25 diameter 6 bar and 20 diameter 6 bar. So my requirement is coming, my steel provided is 4830. So that is why it is coming steel provided is okay. But am I not giving more steel here? So what I'll do, instead of 20 of 6, let me go with 20 of 4. Yeah, now it is okay. You see what is happening now? By providing a 20 diameter 4 bar, I'm giving altogether 2945 plus 1257. I'm giving 4202 mm². My requirement was 4050. I'm giving 4200. I'm pretty okay with that. Not an issue. Done. So now what you do? You design this column. Your column is done. I mean, designing is done. Your detailing should be done. So if this is my column, this is my column. Okay, which is like, let's say 200 by 450. So this is my 200, and this is my 450. And now what I've provided, 25 diameter 6 bar. So I'll provide a 25 diameter in the corners. This is my 25 diameter, 25 diameter 1, 25 diameter 2, 25 diameter 3, 25 diameter 4, and then 25 diameter 5 and 6. Okay, then I need to provide 20 diameter 4 bar. So what I'll do, I'll go with this. So 1 here, 20 diameter, 2, 3, and 4. Done. So in this way, you're supposed to do the column design. I explained you for one column. Of course, again, there is more to this, but that is enough for now. So if I take you to one of the column design here, you can see it here, how it has been done. So you can see the provider 16 diameter 4 bar here, 12 diameter 2 bar. It's a combination of 16 and 12. So here also 16 of 4 and 12 of 2. And come here, see, it's a 16 of 6, 16 of 6, 16 of 6. Again, every area it is 12 of 6, 12 of 6, 12 of 6, 12 of 6, and so on. So in this way, I explained it for one column. The same has to be applied for all other things, and you are supposed to do the designing behind that. All these things has been dealt in more detail in my basic course, but here I just wanted to explain how these things are designed so that you get an idea. So we'll see the beam design here. Okay. Again, very simple. Now let us consider I'm giving a beam of 230 mm. I'll put 230 here, and the depth is 450 mm. Okay. And let us consider the load coming on that is somewhere close to 200 kilonewton. Again, this is simple logic I'm explaining you. Usually beam design, we can make use of ETABS software, and through the ETABS only we'll get the steel on the left side, middle, and right side. Okay. But still, we'll explain you how it has to be done. Okay. Now, with this, for this particular size, 230 by 450 for the load of 200 kilonewton, and we'll go with the M25 grade of concrete. Okay. So what is happening? It's telling that my beam is designed as a doubly reinforced beam. I'm getting the steel in the tension zone and also in the compression zone. So now in the tension zone, I'm supposed to provide 1603 mm² of the steel. So what I'll do, I'll go with the layer 1. I'll provide a 25 diameter, 6 number of bar. Can I do that? Yeah, okay, not that is not required. We'll go with this. I'll provide a 16 diameter. This I'll do 0. Okay, I'll go with 16 diameter. Okay, it's a so it's a huge reinforcement coming. I'll I'll go with 100 only, not an issue for us to understand. Yeah, you see here. Okay, I need to give the area of steel. I'll go with this. I'll make it as W only. Now it is okay. Chalo. Okay, so my steel requirement is 1155. Okay, so what I can do, I'll be providing a 16 diameter 3 bar in the first layer, and then by providing a 16 diameter 3 bar in the first layer, I'm giving 603 mm square of a steel. But again, my requirement is 1155, isn't it? So I'll provide another 16 diameter of 3 bar in the second layer. So now is it okay for me? Yeah, my requirement was 1155, but I'm providing 1206. That means in this particular beam, I'm supposed to provide a 16 diameter 6 bar. But how that 6 bar will look, that I'll show you. You understood how to read the structural drawing. If this is my beam, I'm in the bottom portion, okay? Attention in the bottom portion now. So what I'll be doing, I'll be going with this. So I'll be providing a 16 diameter 1 bar, 16 diameter 2 bar, and this is my 16 diameter 3 bar. This is layer 1. Now I'll go to the layer 2. So layer 2 is also again, you can see 16 diameter 3. So 16 diameter 1 bar, 16 diameter 2 bar, and 16 diameter 3 bar. Pretty simple. Now bottom is done. Top also I'm supposed to provide. So in the top, what is the requirement? So you come to this compression zone. It is 4 mm square. 4 mm square is nothing. It's a small reinforcement. But still, we cannot go below 10 diameter in the beam. Actually, we cannot go below 12, but I'll go with 10 diameter. I'll provide a 10 diameter 2 bar. The steel provided is okay because my requirement is only 4 mm square. But I'm providing a 10, see, 2 bars at any cost you have to provide, because if you don't provide 2 bars, you cannot hang the stirrup. 2 bars at any cost you have to provide. 8 diameter and all, we usually don't go with the beam. 10 is a good diameter. Even though you are giving more, we don't have option. So I'll provide a 10 diameter 2 bar at the top. So let me draw a 10 diameter 2 bar. So this is 10 diameter 1 bar. This is 10 diameter 2 bar. Getting my point? So this is how the beam is designed. Actually, this is not, I mean, this is the way we design. Otherwise, you can directly go to the ETABS model. So in the ETABS model, I had explained you. If I go to the plan part, and if I go to this design, concrete frame design, start design, check. Okay. You can see all these are the steel I'm getting. So whatever steel you were getting it here, no? I'll go back. Here is that. Yeah. Whatever steel you are getting here, this number, whatever you were getting, 1155 and all. So the same thing you'll get in the ETABS software here. Can you see this number? This is the steel what you're getting. 122, 123, 430, 243, 158, 122 mm square. What we do with the help of this, we try to do the manual designing. Okay. So this thing I've explained in my basic course on how to do this manual calculation. I'll not explain it here since I'll be repeating the same thing. If you're interested, you can go and watch my construction methodology course. There are 5 courses on the Ellison platform, or even on the Udemy it is available. So there I've explained all these things, how the manual detailing has to be done. Now you got an idea how the beam designing will be done. So in this way I did for the beam, and the same thing I'll show you here. Practically this is how you get later. Whatever I have drawn, whatever I have drawn and shown you. Can you see the same thing here? So it's a 9-inch by 15-inch is the size of your beam. You can see a 16 diameter 3 bar, 1, 2, 3, and in the top it is a 16 diameter 3 bar. They should have made 16 diameter 3 bar. Uh, we'll not look into this. There's problem with that. We'll go with this. Yeah. See here, this is pretty good. See, they've written 16 diameter 3 bar and 12 diameter 2 bar. That means this bottom one, I'll do it in this way. So this 16 diameter 1, 2, and 3. This is my 16 diameter 3 bar. And then this particular bar, what you can see, no, this one and this one. This is your 12 diameter 2 bar. And on the top, you're providing a 16 diameter 1 bar and 16 diameter 2 bar. You can see it here. 16 of 2 means 16 diameter 2 bar. You're getting my point? So this is how your beam is designed. I explained you for one. Similarly, you're supposed to do it for all the beams in all the floors. And then the manual calculations, you can do it. Okay, pretty simple. Now coming to the stirrup part. So you can see here what is written. They have written 2L-Y8 at 6 inches center to center. It means you have to provide two leg stirrup of 8 mm bar at 6 inches center to center spacing. So again on the Excel sheet you can get it directly. So if I come here, see for this particular area, for this particular shear force, I need to input a shear force. I'll put a shear force of, let us say, 150 kilonewton. Okay, I'm just assuming some value so that we understand the concept. So 150, you can see here the type of stirrup is two leg. It is a 8 diameter bar. So you have to provide at 167. So 167 is not a round figure. Okay. So what we can do, we can lower it down. Always spacing, whatever you are getting, no, lesser than that we need to provide. We cannot increase the spacing. If you're increasing the spacing, the number of stirrup will come down. If the number of stirrup is going to come down, the AST is going to come down. So that in case what will happen, it will not take care of that load. So now what I can say, I can go with this. I'll say provide two leg stirrup. Yeah, two leg stirrup. Okay, two legged. I'm going with 8 dia. Okay, 8 dia. At what is the spacing? 167 is given. But what is the next lower value? It is 150 because 125, 150, 175, 200. This is what we follow. So 167, the next lower is 150. I'll say 150 center to center spacing. Got it? So in this way, you get all these values from the Excel sheet, and through this, you are going to input it here, and the same can be seen it here. Of course, 6 inches comes out to be 150 mm. Here it is written in feet and inches, but that is okay. Two leg, I've written the same thing. 8y also I can write, or 8 dash also can be written at 150. 150 is 6 inches, 6 inches is 150. Got it? Center to center spacing. So in this way, you are supposed to do the design of your beam, and that is how it is to be done. So all these things are done in the structural form. All these Excel sheets will be prepared by them. Great. So we'll see how the slab design is to be done. Okay. Right now I'm looking into the one-way slab design. Okay. So what is this panel size? This panel size are nothing but whenever you do a model, isn't it? So this will be my panel size. For example, if I want to design this particular slab, so I want to know the size of this. This is my panel. So what I can do, I'll go to draw option, and let me unlock the model once. I'll go to draw option and draw dimension lines. Okay, and now let me draw this dimension lines from here to here. So this is 4.2, and from here to here it is 5.575. So let me try to design what kind of slab it will come. Of course it's a two-way slab. I want to design one-way slab. Let me go with this. Okay, yeah, this is 2 meter, and let me go with this. Yeah, this is 4.025. So in the Excel sheet I'll do this 2 meter and 4.025. So my panel size is 4.025, and the other one is 2 meter. Okay, the moment I do that, can you see this is one-way slab? Okay, now it's asking me what is FCK. I'll go with it's M25 grade of concrete, and I'll say Fy is 500 Newton per mm square. And now you have to assume one depth. So initially I'll go with 150 mm, or you can apply the thumb rule which I explained. If your span is up to 3.5 meter, you can go with 125. If it is in between 4 to 5 meter, my span is in between 4 to 5 meter shorter span. Yeah, my shorter span is 2 meter, so I can go with 125 also, not an issue. Because if it is up to 3.5 meter, I told you to go with a slab thickness of 125. So I'll go with 125 here. Assume depth. I'll go with 125. Okay, done. Now it's asking me the dead load of the slab. This dead load, the Excel sheet itself will calculate. It's very simple. Whatever is your thickness, you multiply by the density of the density is 25. Let me do that. I'm not sure. So 25 into no, it's not 25. Yeah, 25 into 0.125. So I'm getting 3.125 exactly. How did this 3.125 come? It's the self weight of the slab. What is the depth of your slab? You're taken 125. And what is the density of that RCC? We take 25 kilonewton per square meter. So 25 into 0.125 is what I'm supposed to do. I'm getting 3.125. I'm getting 3.13. So by default, it will happen on ETABS. Now, this is very important. One is floor finishes and then the live load. Live load concept you understood, that we have to refer IS 875 part 2 code book for residential building, commercial. We'll take it from there. And floor finishes is about the marble that you're going to put. Like once you lay the slab, you're going to put a 50 to 70 thickness of a mortar. Over that, you're going to lay the tiles or the granite. So that entire thickness and the weight of that will be your floor finish. Now, for that, what I have done, I'll go to this slab. This is a slab what I was looking. I'll right click on this. And if I go to the load part, no, okay, they have given shell uniform. Okay, GF common areas. So what I can do is I'll go to assign shell load. In that I'll uniform load set. So common areas, I'll see what is given here. Okay, okay, It's not possible now. Wait. The problem is that we have given it as a set, so all the load will be within that. I'll go to shell load, uniform load set. Yeah, we'll go with the common areas, common area and modify. Okay, where is that common area? Okay, GF common areas, no? Yeah, modify. Okay, they have taken dead load. Dead load in the sense that self weight of the material. Okay, it is 0.3 and your live load is 0.6. So what I'm supposed to do, I'm supposed to apply this load over there. Otherwise, I'll go with a different load. Let me go with for a bedroom. Yeah. So can you see the dead load we have taken 1.5, and in the bedroom, if you remember, the live load is 2 kilonewton per square meter. This load we need to input here. Now let us consider, I'm doing it for the bedroom. Let us consider this particular area is a bedroom. Okay, for time being. What is a dead load? Dead load in the cell self weight. It is 1.5, live is 2. So what I'll do, I'll go here to the Excel sheet. I'll put my floor finish as how much? 1.5, and my live load is 2. So it will add the total load. The total load will be how much? 2 plus 1 is 3, 3 plus 3 is 6, and 6, 6.5, and then 13, 6.63 is the total load coming on your slab. Now it will do all the this thing. What is that calculations? And finally it will tell you what is the reinforcement you are supposed to provide. So it's telling us that you have to. It's a one-way slab. In one-way slab, your shorter span will be main reinforcement. The other will be distribution. So it's telling us that main reinforcement you go with 8 diameter bar at 300 center to center spacing. Your secondary, that is a distribution bar, you provide a 8 diameter bar and you go with 335 center to center spacing. Now I'll go with 10. Let me see. Nothing will happen. Okay. Not an issue. Okay. So now this is the spacing what they have given. Now you can try to play with this. So finally we don't give 300 spacing and all. Finally you are going to get this answer. It is saying that provide 125 thick slab. Okay, that is what we are given an input, and provide a 8 diameter bar at 125 center to center spacing for the main reinforcement, and provide 8 diameter bar at 200 center to center spacing as your secondary reinforcement. Got it? So in this way the Excel sheet is going to do the calculations and all, and it will tell whether the effective depth what you have provided is safe or not. We can even reduce the thickness of our slab, because see, 53 is the actual effective depth required. Through our calculation, it is coming 101, almost 2 times we are safe. You can even reduce it from 125 to 120 or 100 but usually 125 is the minimum what we try to keep. So we are okay with that. You got it? So your reinforcement will be 8 diameter, 8 diameter at 200 and 125. So whatever we got here, no? So practically what we do, when we design the slab, when we give the drawing to the side, we design in this way. You're getting my point? See, this is my bar, what we have given. You have to provide 10 diameter bar at 150 center to center, 10 diameter bar at 150 center to center. See here, 10 diameter bar at 150 center to center, 8 diameter bar at 150 center to center. Now what's it? So from the Excel sheet, we try to design, and then we try to prepare a drawing in this way with the help of AutoCAD software, and then we release the drawing to the side. Pretty simple. This is how you're supposed to do it. Now, in the same way, we have to do it for the two-way slab also. For two-way slab, we have something like this. This is for two-way slab. Okay. Again, the moment I would put shorter span, longer span, and you can see the self weight of the slab will come, floor finishes will come, live load will come, and based on that, it's going to give us what is the steel you're supposed to provide. You can see shorter span direction, a bottom and top steel you'll get, and longer span direction you'll get bottom and top steel. So each people have their own way of designing Excel sheet. You don't have one or two Excel sheet. There's no standard Excel sheets, to be frank. It all depends on the company where you work, and based on that you can, yeah, based on that you can try to prepare your Excel sheets and all. So I given you idea how these things are to be designed, so that you get an idea how these things has to be designed from a structural point of view. Got it? Great. So I hope you have enjoyed my lecture up to here, and this was a complete lecture where I've taken different plans and I've explained you all these things. So there may be a few things maybe I have not gone in a depth, so that you can take in my other course of construction building on the Ellison India, and also in Udemy my courses are available. You can learn from there all these things. The ETABS, there is a separate course, and the same platform you can learn this from my five other courses are there, where I've explained you the complete building sequence and all. So there you'll get even more idea regarding the execution part and all, and that's how it is. So we'll see you in the some other course. Thank you.